Hello everybody and welcome back to your computer science tutorials. Today we're going to be starting section 3 and this is video 1. And section 3 and section 4 are very similar. They both are going to talk about physics. And you're probably wondering, well, why am I learning physics? It's supposed to be computer science. Well, you see, in most video games, typically when you do something, it emulates something in the real world, so it's important to have just a general idea of how physics works. We're not learning how to make I don't know, nuclear physics, but basically with a simple understanding of physics, very simple. You could get by without knowing anything. Basically, you just have to know that things need to look real for people to want to use them. And so I just opened up Unity, and we got our world. I changed up the view a bit. I hope you don't mind. But in our world, we have our first-person controller. And we're going to remove this rigid body, and we're going to remove the collision detector script. And so it's just our standard first-person controller, right? Let me just make sure. In fact, to make sure that it's exactly from scratch, I don't have any weird things going on. If you can just drag in a new first-person controller. Just make sure he's above the ground so he doesn't fall through the earth. And you play, you see he'll fall down. Very standard. Okay. So first things first. Go back here. I have a picture of Newton and an apple falling on him. Apple computer. I hope you get the pun. So we're gonna make our first thing be able to have gravity and fall, which is kind of useful. Believe it or not, gravity is a useful thing. Okay, in fact, I'm gonna do a sphere. So we have a little sphere here, and if we run our game now, you'll notice one thing is that sphere kind of just floats in the air. Looks kind of dumb also because that shouldn't happen. It shouldn't just float in the air. So, easiest solution to this is that we're going to add something called a rigid body. If you type in, if you first start out with this, it's interesting exploring the components tree. So I could click physics, and it would bring in all these really cool things that I'm not gonna really talk about. But rigid body is one thing I will talk about because it's very, very important. And as soon as you add a rigid body onto an object, it means that object now operates based on the laws of physics, for the most part. Basic laws of physics. You see it'll fall to the ground. I can't really, well, I can kind of move it, but the amount that I'm going to move it by is so little, because one, I'm not a rigid body, and two, I can't really apply that much force based off the scripts this first-person controller using, which is a limitation to this first-person controller. So moving on. We're going to say, I'm just going to explain a few of these. If I were to change, okay, so let's start with drag. Drag's, it's not how fast gravity works, it's how much, actually, it's highlighted right there, it's dampening. And basically what that means is that, as this number goes up, your thing gets less and less affected by forces. Angular drag it's the same thing, but in angles. And if that goes away, use gravity. If I unclick this, it'll stop using gravity. Is kinematic. Now, this is very important. Is kinematic means that physics don't affect it. And you're probably wondering, wait, why do I want physics not to affect it if I added an object specifically made for physics to affect it? Well, you see, is kinematic is useful for character controllers, because sometimes you don't want the physics to happen to them exactly how it would in real life, because you want to make magic happen in your game. Also, another reason for is kinematic is that rigid bodies are needed for any type of collision, or any type of collision trigger, which we're going to be learning about in the next chapter. It's needed for those. And you probably, if you looked at our script from the project, that one project, you saw that I had collisions in it, because collisions are very interesting, because that's how most games from the 60s to the even current day, collisions are in everything, platformers especially. Okay, so Interloop, it's basically, it prevents, you could read it. It's used to prevent readback from kinematic Rigidbodies. So it stops like inanimate objects that shouldn't have physics acting on it. Collision detection. There's 3 sets: discrete, continuous, and continuous dynamic. They're just levels of how much it's going to check the object. Discrete is the lowest level, and every rigid body starts out as this because you don't want to have a lot of continuous dynamics because they'll eat up all your resources. And you don't really need continuous dynamic. Some people just use it because it's more convenient. Constraints, if you read, it might not open up at first, but constraints, they freeze different things about the object. For instance, if I clicked freeze the Y position, even if gravity's checked, it's not going to move anywhere. It's going to stay where it is. And now if I alright, so let's do something cooler now. Let's add a cube. And let's make it into a little platform-like thing. So we got our platform. And this is also going to help us explain constraints. Now, what you'll see is that if I go back to the sphere, if I constrain the rotation of the X and the Z, which is like your backwards and forwards, not your up and down, you'll see it's going to fall, but it's sort of just going to stay there. Which is, and you see it doesn't really rotate, it slides off. Which is like it's a cube, it shouldn't even be, it shouldn't slide, it should roll. You could do other things that'll harness that more. For example, if this was not a sphere, it was a cube, it would just stay there, and because it's a cube, it would be flat. It would still slide off, but it would do some interesting things. And if you also lock the Y position, it may have an effect, I'm not really sure. You just look at it to be sure. It slides a little faster. Okay, so constraints are useful if you don't want things rotating. But how it should look is that now that all the constraints and the rotation are off, the ball's gonna roll. And in fact, you can't. If you look in the inspector, you can tell it's rolling. But because it doesn't really have a texture on it, I can't really tell it's moving anywhere. So are we gonna add? Actually, I'll save that for another video. It'll be time better spent on a different topic. Okay, so moving on. So like, if we run this now, you see. Oh wow, it fell. And wait a minute, let me stop the ball. Wait a minute, this doesn't look right. And you'd be correct. Even if you had a rigid body on your character controller, because of how the character controller is programmed, it you really can't influence it. Like, I can kind of stop it, but it sort of just acts like I'm an unmovable wall and will move around me, but the physics will still apply. Eventually, if you stood in front of it enough times, it would lose all of its velocity and just freeze where it is. But that's not gonna happen. So let's delete this cube now. And we have our sphere. It's gonna fall, and because it's not rotating in any direction, it's just gonna fall down and plant itself right here. Okay, so what we're gonna do is we're gonna learn how to interact on a basic level with physics. So let's minimize out of everything, and let's add a component. Let's call it force script. I already have it programmed, actually. I thought I deleted it. Okay. We're going to open the force script, and I'm going to delete everything inside it and explain as I go along what it does. That's what it's going to end up looking like. Let's not delete pragmastrict. But okay, so we want to, let's say you want to make like a canon game. Well, canon games are actually very simple to create, especially the physics behind them. So first we need a direction in which our cannonball is going to launch. So for simplicity, I'm just going to call it that, DRI, or DIR, dir. It means direction. If you hear me say direction, I'm referring to this variable. It's a very common variable. and we're gonna create it as a vector 3 because that's how the physics is going to interact with it. And we're gonna also add another variable called the force. And we'll call it force applied. And this is going to be of type float. And if we run a function update on it, function update, capital. Don't forget your capitals. I'm typing bad today. So now there's two ways we can do this. Well, the first thing is that you need to have some way of doing an input. Say the key E. If you know how to do it, type it in right now. Just test yourself, make sure you know it, because this gets increasingly important when you're programming, that you can make code on your own. But I know that is if input dot get key, and we're gonna leave it as get key, and we'll make it E. And then now here's where this is where like you're gonna be. This is the new type of code. So if we type in rigid body, so we're talking about this rigid body, and we want to. You see all these things is apply explosive force, apply force. First we're gonna start out with a standard force, and you can put in direction, and if you ever get lost about like, because these are random. They're not random. They're all like if you went to do I have it open? Okay, so I have a link to the Unity manual. It's on your computer, and if I were to type in rigid body, my horrible typing skills. Rigid body. This is where you can get a lot of your information on what things do. This is basically the user's manual, and this is not what I wanted actually. I wanted rigid body, maybe this one. No, same thing. Okay, physics then. Let's try add force. Alright, so oh, I'm on the wrong section. You want to be in scripting API. I was in the manual. Here's this is what I wanted, and I'm gonna here they are. So public functions are functions anything can call on it, and you'll see add force is one of them. And they'll show you how to code it. You just type in this. There's different things you can put inside of it. Reading and this is the general function, and reading this is a very, very big skill. I will admit this is very difficult to do. I can't even do it on everything, but this is a skill that you'll learn over time. But this is a scripting API. It's very useful. You see they have learning documentation if you need more help and things like that. But I know how to code it, so I don't really need it. So, also if you typically when you type in a public function like this, like if I add this period, you'll see this list comes up. If this list doesn't come up, say I clicked escape, control space should open up that list. If it doesn't, I'm sorry. And I'm gonna add a force, and if you read this is one method. There's 4 different ways of doing it, and we're just gonna use the second method, which is just add a force from a vector. So we're gonna add our direction vector, and we're gonna multiply our direction vector by the force applied. I feel like something went wrong there. Whatever. Okay, so what what add force does is that it's going to add a force to the object in a direction that's always the same. So if we were to drop this ball, and make sure I saved my script, I did not actually, I lied. So let me do this again. I'm gonna get a view from the inspector so you sort of know what's going on. Let me get a different. Let's do this. I like that view. Okay, so for the run, you'll see that if we make a direction, we'll say we're going up, and forwardish at this angle. No, at your game player angle, it's gonna like travel forward. If we do that, and the force applied, we make it 10. If we were to click E, see, oh, no, wrong direction. Whatever. It'll sort of go up, and it's way, way, way over there. And it sort of travels on an arc, which it could start off your cannon game. But now we can say we can switch the direction. And let's say we wanted to for every 10 units of force, for every unit of force, you want 10 of those force units to be in the X direction, and then you want 100 of those units to be in the Y direction. You could, if you know trigonometry, you could figure out how it's going to travel just from one click of E. But if you run it, I know that this will produce a force that makes it travel way, way up, and not so far forward. And if you're ever wondering about how the physics system works, oh, that was weird. And add force always applies in the same direction. So if you have a static game, and if I hold the button longer, it'll sort of be different. And because it's moving right now, I can sort of influence the path. That's what's going on. Okay, so that's kind of how you'd make a cannon game. And as I was saying before, physics in Unity is calculated using the metric system. In fact, most physics is. So if you're doing like feet per second or anything like that, your calculations are going to be a little fudged and not looking right. So if you want to just make actual calculated physics in Unity, it uses meters, and a force applied would be in newtons. And that's it for this. Oh, actually, let me hold on here. Alright, so I showed you add force, but we also sometimes we don't want it to add in the same direction. We want to add a force relative to its position in the coordinate plane. So if we do add force, add force or add relative force, and we can do the same thing, direction times by the force applied, and save that, and we're to run this, and it runs. There we go. You'll see that it's going to apply this force, but now it starts rolling. It's going the other way, and it's because it's rolling, we sort of get this like interesting motion where I just lost it, and it's way over there, and it's gone. Yeah, because it was rolling, when I applied a force relative, that means that it's applying a force at like the X, Y, and if you look at this little gimbal right here, at the X, Y, and Z, but as the object moves, the gimbal also moves with it, based off like the origin of like its rotation. So as it moves, the force will apply relative to the new axis that it's at, which can be useful if you want to do some different stuff. One being, say you're doing like a cannon game where you could shoot it again. Maybe you wanted to shoot it like a rocket game. I don't know. Yeah, a rocket game would be a good example, because as the thrusters would move out from your rocket ship, you'd have you wouldn't just keep going up if your rocket ship was pointing down. You'd be flying downwards very fast. So that's what you would use for like relative force. You can also do some other cool things, like you can make like shields float around your guys and shoot them out like spears or I'm saying spears, but I said spheres. That's weird. But you could like do that where they like rotate around using like that circular script, and then you like launch them forward at different times, which is interesting, and you can make a lot of cool effects. So that's basically it to physics. So I'll see you guys next time.